A rock 4 billion miles from the sun, too small to keep its planet card, too cold to have weather in any normal sense of the word, is somehow air conditioning itself, not metaphorically, actually cooling its own sky using nothing but haze. Nobody asked it to do this. Nobody expected it to do this. And yet here we are, watching a demoted dwarf planet outperform half the HVAC systems in Texas. Stick around, because I'm going to walk you through what scientists have actually confirmed about Pluto. No exaggerated headlines, just what the data says. And if you like watching science get slowly, deliciously weirder, hit subscribe, because this is not the last time Pluto is going to embarrass our expectations. Let's rewind, because Pluto's resume is stranger than people remember. In 1930, a 24-year-old lab assistant named Clyde Tombaugh was handed the astronomical equivalent of, "Please review these 400 spreadsheets for typos." Compare photographic plates of the same patch of sky night after night, looking for one dot that moved. Most nights, nothing. One night in February, something moved. That dot became Pluto. For most of the 20th century, it held the title of ninth planet, a title earned largely because nobody had a telescope good enough to prove otherwise. Some early estimates of Pluto's size were wildly inflated, built on gravitational anomalies in Neptune's orbit that later turned out to be measurement error. So for decades, the public's mental image of Pluto was built on guesswork, stacked on more guesswork, wearing a trench coat. Then in 2006, the International Astronomical Union took a vote and reclassified Pluto as a dwarf planet, the only world in history to be discovered, celebrated, and then formally voted out of its own category. Somewhere, there is still a printed encyclopedia insisting otherwise. That should have been the end of the story. Small, cold, filed under irrelevant. It was not. In July 2015, after 9.5 years traveling across billions of miles of nothing, NASA's New Horizons spacecraft screamed past Pluto at more than 30,000 miles per hour. No orbit, no do-over. A few minutes to grab everything it could before vanishing into the Kuiper Belt forever. The least forgiving photo shoot in human history. What it sent back rewired assumptions instantly. A massive, pale, heart-shaped plain, smooth and suspiciously young next to ancient, cratered terrain nearby. Mountains of water ice over 10,000 feet tall, frozen so hard it behaves like solid rock rather than anything you'd put in a drink. Fields of nitrogen ice apparently churning in slow convection, suggesting heat and motion under a crust everyone had assumed was completely dead. Layers of blue haze rising hundreds of miles above the surface, visible even backlit by the sun. This was not a frozen leftover. This looked like a world still in the process of becoming something. And the New Horizons kept flying. One look, forever. Whatever it missed stayed a mystery for years. Because what researchers needed next wasn't a better photo. It was a way to read Pluto's chemistry from Earth without launching another multi-billion-dollar dice roll into deep space. Here's the difference. New Horizons flew by and took a picture. The James Webb Space Telescope doesn't fly anywhere. It reads light. Breaking it into wavelengths to extract a precise chemical fingerprint from a target, it's not even close to. Pointed at a faint pinprick of reflected sunlight billions of miles away, it can tell you what molecules are present and how warm different atmospheric layers are, all without moving an inch. The technical problem was that Pluto and its giant moon, Charon, sit so close together in Webb's field of view that separating their heat signatures was nearly impossible with earlier telescopes. It wasn't that the signal wasn't there, it's that instruments couldn't tell how much heat was Pluto's and how much was bleeding in from Charon next door. Webb's larger mirror and sharper infrared instruments finally solved that. Starting in 2022, once fully calibrated, Webb turned toward Pluto, and what came back wasn't a prettier photo. It was closer to a full medical workup on a planet that isn't even a planet anymore. If you want space explained without the jargon dump, drop a like. It genuinely helps this reach people who'd enjoy it. Back in 2017, planetary scientist Xi Zhang at UC Santa Cruz proposed something that sounded backwards. On Saturn's moon Titan, atmospheric haze traps heat like a blanket. Zhang argued Pluto's haze might do the opposite. Absorb sunlight during the day, then radiate that energy back into space as infrared heat faster than Pluto's paper-thin atmosphere could ever hold onto it. Not a blanket, a radiator, actively bleeding away heat from a world that had almost none to spare in the first place. At the time, this idea landed about as well as you'd expect an idea like that to land, mostly because there was no instrument sensitive enough to test it. Fast forward to Webb's mid-infrared instrument, sensitive enough to finally separate Pluto's thermal signal from Charon's. A team led by astronomer Tanguy Bertrand at the Paris Observatory used it to measure Pluto's atmosphere directly. Results, published in Nature Astronomy in June 2025, confirmed almost exactly what Zhang predicted 8 years earlier. And Pluto's upper atmosphere turned out to be roughly 30 degrees colder than models expected. Researchers are now calling this a genuinely new kind of climate, Pluto isn't cold just because it's far from the sun. It is, in a very real sense, actively refrigerating itself. And scientists are still working out whether the same trick applies to other hazy worlds, like Neptune's moon Triton, or whether it says anything about what Earth's own atmosphere looked like billions of years before oxygen showed up. A demoted rock, 4 billion miles out, quietly running climate control nobody installed. We'll pick this apart further and get into the moon that's been secretly eating Pluto's atmosphere for 1 billion years. Even the faint trickle of sunlight that reaches Pluto is enough to break apart methane molecules high in its atmosphere. Those fragments don't vanish. They recombine into heavier, reddish-brown compounds called tholins, which drift down and settle on the surface. New Horizons caught early traces of this in 2015. Later observations have refined the picture since. Here's the part that tends to stop people. Tholins belong to the same organic molecule family some scientists think may have rained onto early Earth, potentially supplying raw material for the chemistry that eventually led to life here. On Pluto, that same basic process has apparently been running for roughly 4 billion years. A slow, continuous snowfall of biological building blocks, landing on a surface too frozen for any of it to ever spark into anything alive. A 4 billion year science experiment with absolutely nobody home to appreciate it. To put the cold in perspective, sunlight reaching Pluto is about 1,000 times fainter than on Earth. So high noon, there looks like heavy twilight here. Surface temperatures sit around 387 to 369, more than 250 degrees colder than the coldest temperature ever recorded on Earth. At that temperature, nitrogen, the gas making up most of the air in your lungs right now, freezes solid. The atmosphere around you would, on Pluto, simply become part of the landscape. Pluto has been slowly leaking into space for billions of years. Methane and other light molecules drift up through the thin atmosphere, slip past Pluto's weak gravity, and escape. Scientists knew this. What they didn't know for a long time was where it was all going. It wasn't vanishing. Something was catching it. Pluto's largest companion, Charon, a battered ice moon roughly 750 miles across, orbits in an extremely tight gravitational lock with Pluto. Most of Charon's surface is unremarkable ancient water ice, except at its poles, which are stained a deep reddish brown, darker than anything else on the moon. Researchers suspected a connection to material escaping Pluto for years, but lacked the tools to confirm it. The mechanism comes down to Charon's absurdly long seasons. Because of its tilt, Charon's northern pole spends multiple decades in total darkness at a stretch. No sunlight at all. That makes the pole an extremely effective cold trap. Escaping methane drifts in, freezes solid because there's no warmth to keep it as gas, and sits accumulating for years. When sunlight finally returns, it doesn't melt that methane away. Instead, ultraviolet radiation and cosmic rays break the frozen molecules apart and reassemble them into heavier reddish compounds, locking the color in permanently rather than letting it evaporate. A widely cited 2016 study described the whole loop. Methane escapes Pluto, crosses roughly 12,000 miles of space, gets captured by Charon's gravity, freezes onto its polar surface, and gets cooked by radiation into the same organic compounds coloring Pluto's own surface. Two worlds, locked together, quietly trading atmosphere and color since before either one had a name. Pluto isn't just being studied, it's being slowly redecorated by its own moon. Charon had one more surprise. In October 2024, a team led by Sylvia Protopapa at the Southwest Research Institute used Webb data to confirm both carbon dioxide and hydrogen peroxide frozen onto Charon's surface. The carbon dioxide likely came from underground material exposed by impact craters. The hydrogen peroxide appears to have formed from years of radiation rearranging Charon's water ice. This exact combination had never been confirmed on Charon before. If this is stranger than you expected, drop a comment. It genuinely shapes what gets covered next. Picture standing there. The sun is still visible, but only as an intensely bright point smaller than a pinhead at arm's length. No real warmth, no glare, you could stare straight at it. The sky sits in a permanent grayish-blue gloom, never fully day, never fully night. The ground doesn't behave like ice. At nearly 400 below zero, water ice stops being slippery and starts behaving like solid rock, hard enough to ring almost like metal if struck. The atmosphere, roughly 100,000 times thinner than Earth's, offers nothing to breathe, though the cold would freeze exposed skin long before that became the immediate problem. And overhead, fixed in exactly the same spot forever, Charon. The two worlds are close enough in size that they don't orbit each other the way Earth orbits its moon. They orbit a shared point in empty space between them, locked so tightly each always shows the same face to the other. A billion-year staring contest neither one can end. In a region called Tartarus Dorsa, New Horizons photographed something no spacecraft had documented anywhere else. Rows of jagged ice blades, over 500 feet tall, made of frozen methane, arranged in long parallel ridges. Similar but much smaller formations exist on Earth in high-altitude deserts called penitentes, rarely taller than a person. A 2025 analysis of the original New Horizons data suggests Pluto's version may wrap around as much as 60% of its equator, an entire ring of jagged frozen terrain circling the planet that isn't a planet. South of the famous heart-shaped plain, two enormous isolated peaks rise from the landscape that researchers still can't fully explain. One is roughly 13,000 feet tall. The other may reach close to 20,000 feet. Both have deep depressions at their summits ringed by fractures, resembling cooled lava flows, except there's no molten rock on Pluto. If these are what they appear to be, they're cryovolcanoes. Structures that once erupted not with melted stone, but with a slurry of water, ammonia, and methane forced up from beneath the icy crust. Something down there was warm enough, recently enough, to push liquid all the way to the surface. Which leads to the most debated idea of all: a possible hidden ocean roughly 100 miles beneath Pluto's surface, kept liquid by slow radioactive decay in its rocky core. The evidence isn't a photo, it's a pattern. Cracks and ridges across the surface line up the way you'd expect from a subsurface liquid layer shifting beneath the crust, and that heart-shaped plain sits directly above what looks like a positive gravity anomaly, a denser concentration of something underneath. Similar hidden oceans are already suspected under Europa and Enceladus, both of which show far more obvious evidence, including active geysers on Enceladus. If a body as small and cold as Pluto is hiding something similar, buried oceans might be a common feature of icy worlds throughout the outer solar system. Not a rare exception. Right now, there's no funded mission back to Pluto, no lander, no orbiter, nothing on the books, largely because the trip alone takes the better part of a decade. And outer solar system exploration rarely wins funding battles against missions that return results in a few years instead of a few decades. Not because scientists lost interest, because the math is brutal. For now, Webb is the only tool we have, checking back in every few months whenever Pluto swings into view, adding another data point, and, almost without fail, making the picture stranger than it was before. Pluto sits inside the Kuiper Belt, a ring of icy debris beyond Neptune, home to hundreds of thousands of objects wider than 60 miles, plus an estimated trillion or more comets, a region hundreds of times larger than the asteroid belt between Mars and Jupiter, and almost entirely unexplored. Only one spacecraft has ever gone deep enough to photograph any of it up close, and it only managed close flybys of two objects out of the hundreds of thousands believed to be out there. So here's where this actually lands. Pluto was never the dead end that a single 2006 vote made it look like. If one small, formerly dismissed dwarf planet is quietly refrigerating its own sky, leaking atmosphere onto its moon, and possibly hiding a liquid ocean under a shell of ice, it's worth wondering what the trillion or so other objects out there that we've barely glanced at are hiding too. If you want more stories built on real published research instead of exaggerated headlines, subscribe and turn on notifications. Webb is still pointing back at Pluto every few months, and there's a real chance the next data drop makes this stranger still. Thanks for watching. I'll see you in the next one.